Hello everyone, good morning, good evening, good afternoon, and to some good night. My name is Bharat, and I have been working in one of the universities in Bhutan for the last 19 to 20 years. And I just wanted to create some online content and put it on YouTube so that I can help some students. This is the first video that I have actually created, and then I'm going to upload it. So if I had made any mistakes, kindly comment in the comment section, give your suggestions. So I'm not going to show my video all the time. So let me put up my video, then we'll get into the topic straight forward. So once again, welcome to my channel. So in today's video, we are going to talk about Vapor Compression Refrigeration Cycle. So we will understand how your refrigerator works using a very important concept in thermodynamics. That is the Vapor Compression Refrigeration Cycle. So this is going to be the basic principle behind most household freezes and air conditioners like ACs. So here, if you see, let's start with the thermodynamic side. As per the second law of thermodynamics, it is impossible for a cyclic process to transfer heat from a colder body to a hotter body without the help of external work. But then take a look inside a refrigerator at this picture. It is cold inside here, right? You can even see some white paper. Now we are trying to transfer this heat from this colder region to outside in the warmer region. So that means this is not going to be the spontaneous process. This is going to be the non-spontaneous process. You are trying to extract heat from the colder region and dump the heat into the hotter region. So at first, this may seems like it violates the second law of thermodynamics, but it doesn't. If you clearly see the definition of second law of thermodynamics, the heat transfer is possible because we supply external work here in this case. So in the form of electricity to run the compressor. This fridge will have the compressor behind, or the AC will have the compressor in the outer unit. So that's exactly what the second law allows. Heat can move from the colder region to the hotter region if external work is applied. So in this case, we are applying the external work in the form of electricity that moves the compressor. So Vapor Compression Refrigeration Cycle is a closed loop. I'm going to show you the loop later on, where a special fluid known as refrigerant moves through different components, changing pressure and temperature. And what is the goal? The goal is very simple: to absorb heat from inside of the fridge and release it outside. Absorb heat inside, and that particular heat we release it outside. And the heat carrier is done by the refrigerant that we use. Now let's look into the refrigerant now. So the refrigerant is a special fluid that circulates throughout the system, be it in AC or in the fridge. We have to put this one, and then it circulates throughout the system, much like a blood in the human body that helps to regulate temperature. So this also plays a crucial role in the heat transfer that I have mentioned just now. So like evaporating at low temperature to absorb heat from inside of the fridge that I have shown just now, and then condensing outside of the fridge to release that heat. Or if you want to take AC as the example, so inside the room, the heat is collected, and the refrigerant will actually dispose the heat outside. That happens in the AC, and this is what is going to happen in the fridge as well. So there are different types of refrigerant depending upon whether they are used in refrigerator or air conditioners. A common example is this one, R134A. So which is widely used in the household refrigerator, especially in India and then in the South Asian region. So to work well in a refrigerant must have two important properties, two key properties. And one of them is that it should have a very low boiling point. If you see here, if you take this refrigerant R134A, the boiling point is negative 26.1. I'll tell you why this much lower boiling point is required later on. And then the second key property is that it should have high latent heat of vaporization. For example, in this case, the latent heat of vaporization, if you take this as the refrigerant, it is 216 kilojoule per kg. So this means that this absorbs a lot of heat when it gets inside the freeze or refrigerator or inside the room through the piping system and dumps the heat outside. So we are going to talk about all this one later on, little bit later. Okay, now let's look into the instrumentation and flow diagram of vapor compression refrigeration system. So there are four main components. Only four components are there which are very, very important. Let's start from a compressor, a condenser, an expansion valve, and an evaporator. So these are the four most important components that are there in the vapor compression refrigeration cycle, be it in the refrigerator or in the air conditioners. Now let's connect all these four components that I have shown you just now with the piping system. It's connected, right? The compressor is connected to the condenser. The condenser is linked to the expansion valve, which then connects to the evaporator. Finally, the evaporator is connected back to the compressor, completing one refrigeration cycle. Now let's look into the function of all these four components like expansion valve, condenser, compressor, and evaporator. So what are the functions or what are the roles? So let's again begin with the compressor. Here you can see it is used to increase the pressure and raise the temperature. Condenser, it rejects the heat after collecting the heat from inside of the house, and by rejecting the heat, temperature drops, and therefore the vapor condenses back into liquid. And expansion valve, this is kind of the brain of the ACs or freeze. So it drops the pressure. By doing that on, it cools the refrigerant. And finally, we have the evaporator. The role of the evaporator is to absorb heat and to evaporate the liquid. I'll tell you where is the evaporator located, where are the condensers, and then compressor and expansion valve located later on. Okay, let's look into where they are located just now before we go ahead. In a freeze, the evaporator and expansion valve, these two, are located inside the freeze, while the condenser and then the compressor, they are located at the back of the freeze or the refrigerator. So backside, you may have seen the long coils going on like that. That is nothing but the condenser. And then at the lower base of the freeze, you see the compressor, a kind of motor moving all the time. All right, so we'll see the next slide. So basically, the compressor, this compressor, and then the expansion valve, they work together to maintain pressure difference in the refrigeration cycle. See, on the right side of the compressor and then the expansion valve, we have high pressure side. And on the left side, we have low pressure side. Why high pressure side? Because the compressor has compressed the vapor, and then the temperature also increases, so pressure is high. But then once that vapor or the liquid crosses this expansion valve, mostly liquid crosses this expansion valve, then the pressure decreases significantly. Temperature also decreases significantly. So left side we have low pressure side, and right side is known as high pressure side. Now this is the last slide, and this is the most important slide. All right, this is the most important slide, which talks about the the vapor compression refrigeration cycle in a nutshell. So if you are writing the exam, I think only this slide is enough. So the reason as to why I have actually gone through all these other slides is to make sure that you understand the concept in between. So as I have mentioned, this is the last slide of our lecture on the Vapor Compression Refrigeration Cycle. With all the components and their roles already in mind, understanding the process becomes much easier now. So let's start with this, let's start with this compressor. Okay, compressor. So the compressor takes in low pressure, see here, low pressure, low temperature refrigerant vapor through the suction line and compresses into high pressure, high temperature vapor. So the moment you have to understand one thing, whenever we are compressing something, the temperature increases. That means the system is the surrounding is doing work on the system. So system gains the internal energy, which is related to the heat. So the temperature increases, and because you are compressing, not only the temperature, the pressure also increases. The hot vapor then flows through the vapor line, this one, into the condenser. Okay, so as I have mentioned already, this condenser in freeze or refrigerator is located at the back side, and in AC this condenser is located in the outdoor unit, okay, not inside the room but outside the room. So you have to understand this. Some of you may have seen how this condenser is made up in AC. So the condenser consists of a long copper coils where the refrigerant releases heat to the surrounding. That means heat rejection takes place. Now what means, there is some condition. If the surrounding air temperature is higher than the temperature of the refrigerant, then the heat exchange may not take place. So the outside temperature has to be lower than the temperature of the refrigerant. But thanks to compressor, it makes sure that the temperature of the resistant is almost always higher than the temperature of the ambient air. So therefore the heat exchange easily takes place. So it releases the heat outside, it rejects the heat outside, cooling the vapor. So heat rejection takes place and then vapor becomes cool. So when vapor becomes cool, the phase transfer will take place. So therefore the vapor becomes liquid. So therefore the vapor becomes liquid. So as it loses heat, the refrigerant changes from vapor to liquid phase. So the liquid refrigerant remains at high pressure, but the temperature decreases significantly. This is what you have to know. The pressure is still high, but because of the condensation system that has taken place, the temperature has decreased. So here I have mentioned high pressure, medium temperature, or you can even say high temperature. Okay, you can say high pressure, medium temperature, liquid refrigerant. I am no more going to say or no more going to call it as vapor refrigerant. It is now liquid refrigerant. After condensation, the vapor has condensed into liquid. All right. Now next, the liquid refrigerant, this one, passes through the expansion valve. So I have already mentioned in the AC or in the freeze, this expansion valve acts like the brain of the human being. So which works on the Joule-Thomson effect. So when the refrigerant moves from the high pressure to low pressure, okay, here it is high pressure and suddenly this becomes bigger. Inside we have capillary tubes. So the content, that refrigerant liquid moves through the capillary tube and suddenly it opens into the bigger tube. So therefore from a smaller restricted area to a bigger area. So therefore the expansion of the liquid takes place. I think you may have already gone through this Joule-Thomson effect. There is one experiment where rail gas is compressed from the high compression cylinder to the low compression cylinder through the throttle. So when the gas escapes through the throttle and then suddenly expands, the cooling takes place. So this expansion valve actually carries the the principle of Joule-Thomson effect. So it goes inside. There are some capillary tubes, so it gets into the smaller capillary tubes. The liquid gets into the smaller capillary tubes, and suddenly when it opens into the bigger pipe, expansion takes place. So when sudden expansion takes place, some of the gas also, some of the liquid also gets back into vapor, but mostly it is liquid. Okay, and then the temperature drops. The temperature drops significantly. To give you the context, here the temperature of the liquid is at around 35 to 40 degrees Celsius. And after crossing the expansion valve, because of the Joule-Thomson effect, the temperature is negative 25 to negative 30 degrees Celsius. You can just see this is the main thing that works in the ACs or in the refrigerator. And then some of the components is then converted into the vapor phase because of certain expansion, but mostly it is in the liquid phase. Then it gets into the evaporator. It gets into the evaporator. Now this is the most important part. The reason as to why people have done all this work, the engineers have done all this work, is to get into this one, collect the heat from here and then reject the heat here. We collect the heat from inside of the freeze and reject the heat from back of the freeze. We collect the heat from inside of the room in the AC and we reject the heat from outside. So let's look here what happens. So after the expansion valve, the low pressure, low temperature liquid refrigerant, and then some has converted into vapor form, enters the evaporator. This is the evaporator. Now this evaporator is located inside the freeze or refrigerator, typically behind the vegetable compartment. I think you may not see also, it is just behind the vegetable compartment hidden. So here most crucial process takes place, like heat exchange occurs. The refrigerant, which is very cold, negative 25 to negative 30 degrees Celsius, absorbs heat from inside of the freeze or inside of the room if you talk from AC's perspective, and it begins to boil. So do you remember that I said there are two important properties, there has to be two important properties for the refrigerant. One is very low boiling point, so it can boil even at negative 26 degrees Celsius. Now let's imagine that you have put ice cream in the freezer at negative 25 degrees Celsius. And in your freeze or in your refrigerator, there is a refrigerant which boils at negative 20 degrees Celsius. Then it is not going to maintain that temperature of negative 25 degrees Celsius. This is the reason, okay? It has to boil at very, very low temperature. So please keep this in mind. So since the refrigerator boils at very low temperature like negative 22 to negative 25 degrees Celsius, here boiling needs heat. So again, one more concept, science concept is required. So what is boiling, right? So when the liquid starts boiling, it needs heat. That means from the liquid phase to, convert the phase into gaseous phase, it needs heat energy. So that this heat energy can get inside the liquid medium and break the intermolecular bonds. So therefore the liquid converts into vapor. Without this heat, the liquid is not going to convert into vapor. So heat is required. So what happened? That is why we wanted this refrigerant to boil inside the freeze. Actually, the refrigerant is boiling inside the freeze, or it is boiling inside the indoor unit of the ACs, right? So boiling means it needs energy, it needs heat, and inside the freeze, it takes heat from just inside of the freeze, the inner environment of the freeze. If you think from the perspective of ACs, it takes heat from inside the room. The indoor unit is going to take heat from inside of the room. This evaporator is nothing but what you put in the indoor unit. So the actual concept is here. Boiling means changing the phase from liquid phase to vapor phase. Boiling needs some kind of latent heat of vaporization. So it has to get the heat. The heat comes from within the surrounding of the freeze or within the room. Now, again, there is one interesting thing that happens, okay? Because it tries to take out the heat, that is why cooling is caused. But during the boiling, the refrigerant temperature stays same, because whatever heat it has taken to boil, whatever heat it has taken from inside of the freeze, from the food item, from the vegetable item, whatever heat it has extracted, or from the room, whatever heat it has extracted, is actually used in, or is the expenditure is done in, breaking the intermolecular bond so that it boils, not changing the temperature of the liquid, right? So that is the most important thing. So finally, the low pressure after this. Finally, the low pressure, low temperature. Now pressure is low because from here the pressure has decreased. Temperature is low, from here the temperature has decreased. So low pressure, low temperature vapor returns through this vapor line and then through the suction line into the compressor. And by doing that, the cycle is completed and this cycle repeats. So this is the overall working principle of how the refrigerator, freeze, or be it the ACs works based on the principle of vapor compression refrigeration cycle. So at the end, I would like to once again thank you for watching. I hope you now have a better idea of how the vapor compression cycle works and how refrigerator use it to keep things cool. If you find this video useful, please like, share, and subscribe for more simple science and engineering videos. And then if you want me to make videos on certain topics, please, you can give it in the comment section. I'll try to make that video. And then see you next time. And thank you so much. Goodbye.